Welcome to Science Aura. I'm Dr. Sachivale. Imagine a multi-billion-dollar guided missile destroyer gliding across the deep blue of the Pacific. It seems completely invincible, a modern marvel of naval engineering. Yet, beneath the surface of this military dominance, a radical shift is occurring. A tiny, silent threat is rising from the waves, ready to turn the rules of maritime engagement completely on their head. Historically, controlling the oceans required massive capital investments. Great nations built gargantuan warships, aircraft carriers, and complex defense networks. But today, the economics of warfare are being rewritten. How does a defense budget of billions stand up against an offensive technology that costs less than a family sedan? This is the paradox of modern asymmetric naval conflict. Meet the Bolt M. It is not a lumbering aircraft or a massive missile. Weighing a mere 6 kilograms, this ultra-lightweight, smart, unmanned aerial vehicle is designed for one specific purpose: to dismantle the supremacy of massive naval vessels. It represents a paradigm shift where size no longer dictates power on the global stage. The core philosophy behind the Bolt M is simple yet revolutionary: absolute decentralization. Instead of relying on a centralized airfield or a massive command ship, a single soldier standing on a remote coastline or a small inflatable boat can launch a devastating strike. It democratizes precision air support for the individual infantryman. Modern warships are designed to detect and intercept fast-moving jets and massive anti-ship missiles. Their radar systems scan the horizon for high-altitude threats. But what happens when the threat is smaller than a seabird, flies just feet above the water, and emits almost no thermal signature? Traditional defense networks suddenly find themselves blind. To understand the Bolt M, we must look at the evolution of asymmetric warfare. Throughout history, smaller forces have used ingenuity to defeat larger empires. From ancient guerrilla tactics to modern improvised explosive devices, the goal has always been to exploit the vulnerabilities of overextended giants. The Bolt M is the digital evolution of this ancient concept. In the early 21st century, drones were large, expensive, and operated by distant crews in air-conditioned trailers. They were eyes in the sky, used primarily for surveillance. However, as consumer electronics miniaturized and battery technology advanced, the barrier to entry plummeted, paving the way for localized tactical drone operations. Recent conflicts have shown that even the most advanced naval vessels are vulnerable to low-cost, coordinated attack. Sea drones and modified commercial quadcopters have successfully damaged multi-million-dollar warships in enclosed seas. These events sent shockwaves through naval command centers worldwide, proving that the era of uncontested naval dominance is over. While improvised commercial drones proved the concept, they suffered from major limitations. They lacked military-grade encryption, were easily jammed, and carried small, inefficient payloads. Militaries realized they needed a purpose-built, ruggedized, and highly intelligent microweapon designed specifically for contested maritime environments. Engineers set out to design a system that combined the portability of a consumer drone with the lethality of a guided missile. The result was the Bolt M, a weapon system that fits in a standard backpack, deploys in under 2 minutes, and possesses the intelligence to strike with surgical precision without human intervention. At the heart of the Bolt M's physical design is its advanced material composition. The chassis is constructed from a proprietary hexagonal carbon fiber weave. This material provides an incredible strength-to-weight ratio, allowing the drone to withstand high-velocity winds and rough handling while keeping the total weight at an astonishing 6 kilograms. Traditional fixed-wing drones require runways or bulky pneumatic launchers. The Bolt M overcomes this limitation with its vertical takeoff and landing or VTOL capability. Utilizing 4 high-efficiency electric rotors, it can lift off vertically from confined spaces including dense forest clearings, rocky coastlines, or the deck of a swaying boat. Once the Bolt M reaches its transition altitude, its propulsion system shifts. The drone utilizes a highly efficient pusher propeller system for forward flight. This dual propulsion design allows it to combine the launch flexibility of a helicopter with the long-range, high-speed cruise efficiency of a traditional airplane. In modern warfare, sound is a giveaway. The Bolt M features custom-designed, swept-wing propeller blades that drastically reduce acoustic noise. At cruising altitude, the drone is virtually silent to the human ear and acoustic detection systems on the ground, allowing it to slip past enemy sentries undetected. Acoustic stealth is only half the battle. Radar stealth is equally critical. The Bolt M's geometric shape is carefully contoured to scatter radar waves away from the receiver. Combined with radar-absorbing coatings on its carbon fiber chassis, its radar cross-section is reduced to that of a small sparrow, rendering traditional air defense radars useless. Infrared sensors are another major threat. Traditional combustion engines emit massive amounts of heat, creating an easy target for heat-seeking missiles. The Bolt M's electric propulsion system produces almost no thermal signature. Heat-dissipating vents are strategically placed to blend any residual warmth into the surrounding air current. Logistical footprint can make or break a military operation. The Bolt M features foldable rotor arms and a modular tail assembly. This allows the entire system to be collapsed into a rugged, shock-proof casing that can easily fit into standard military transport vehicles, helicopters, or even individual infantry rucksacks. The ocean is a harsh, unforgiving environment characterized by salt spray, high humidity, and extreme temperatures. The Bolt M is fully ruggedized with IP67 rated ingress protection. Its internal electronics are sealed in a pressurized, nitrogen-filled compartment, preventing corrosion and ensuring reliable operation in heavy rain or salt fog. Powering this advanced machine is a high-energy density solid-state lithium-sulfur battery. This cutting-edge battery technology provides twice the energy density of conventional lithium-ion cells, giving the Bolt M an impressive operational range and loiter time without adding unnecessary weight to the airframe. Control of the Bolt M is maintained via a ruggedized handheld tablet that serves as the ground control station. Designed to withstand drops onto concrete and immersion in water, this interface provides the operator with real-time video feeds, telemetry data, and mission planning tools, all secured by military-grade encryption. One of the most revolutionary aspects of the Bolt M is its modular payload bay. Unlike traditional missiles that are built with a single fixed warhead, the Bolt M features a quick-release bay at its nose. This allows operators to swap warheads in seconds, transforming the drone from a surveillance asset into a lethal weapon on the fly. For targeting unarmored vessels, personnel, or light radar installations, the Bolt M can be equipped with a high-explosive fragmentation warhead. Upon detonation, this warhead releases thousands of high-velocity tungsten fragments designed to shred sensitive electronic equipment, external sensors, and communication arrays on a warship. When facing heavily armored targets like patrol boats or command bunkers, the drone utilizes a high-explosive anti-tank or heat-shaped charge warhead. This module uses a copper cone that collapses upon impact, creating a hyper-velocity jet of molten metal capable of punching through thick steel hull plating. Not all missions require kinetic destruction. The Bolt M can also carry an electronic warfare payload. This module emits focused radio frequency interference, jamming enemy communications, disrupting local radar networks, and creating a blind spot in the adversary's air defense umbrella, paving the way for larger strikes. For long-endurance intelligence gathering, the drone is equipped with a high-definition multispectral camera payload. This includes thermal imaging, night vision, and optical zoom capabilities, allowing the Bolt M to act as a silent scout, mapping enemy positions and transmitting coordinates back to command centers. In the chaos of battle, circumstances change in an instant. An operator might launch a reconnaissance drone only to discover a high-value target that must be destroyed immediately. The rapid swap mechanism allows a soldier to land the drone, swap the sensor for a warhead, and relaunch within 90 seconds. In gray zone conflicts, where outright destruction is not desired, the Bolt M can deploy non-lethal payloads. These include high-intensity strobe lights, acoustic hailing devices, or paint marking canisters, allowing maritime security forces to deter encroaching vessels without escalating to kinetic violence. Safety is paramount for the operators. The Bolt M's warheads feature a multi-stage electronic safety and arming device. The warhead remains completely inert until the drone has flown a safe distance from the operator, reached its cruising altitude, and confirmed its target lock, eliminating the risk of accidental detonation. To maximize the effectiveness of its payloads, the Bolt M's flight computer automatically adjusts the angle of impact based on the selected warhead. For shaped charges, it executes a steep, top-down dive to strike thin deck armor. For fragmentation warheads, it detonates slightly above the target for maximum spread. This modularity also represents a massive cost savings. Instead of purchasing and maintaining separate fleets of reconnaissance drones and guided missiles, militaries only need to stock one standard airframe and a variety of specialized payload modules, drastically simplifying logistics and reducing overall defense spending. The true genius of the Bolt M lies not in its physical structure, but in its digital brain. Integrated directly into the drone's avionics is a high-performance edge computing AI processor. This processor is capable of running complex neural networks in real time, allowing the drone to perceive and understand its environment. In a modern conflict, the Global Positioning System, or GPS, is the first thing to be jammed. A standard drone becomes a useless brick without GPS. The Bolt M, however, utilizes visual inertial odometry and terrain relative navigation. By analyzing the ground or sea surface below, the AI can navigate accurately without GPS. The AI's primary task is automated target recognition. Using deep learning algorithms trained on thousands of military assets, the Bolt M can identify, classify, and track specific vessels. It can distinguish between a civilian fishing boat, a friendly patrol craft, and an enemy destroyer, completely eliminating human identification errors. Because the AI processing is done entirely on the edge, meaning on board the drone itself, the Bolt M does not require a continuous high bandwidth data link to a ground station. This makes the drone immune to electronic jamming, as there is no signal to intercept or disrupt once the mission is initiated. The sky is full of obstacles, from power lines to sudden gusts of wind. The Bolt M's AI continuously calculates the most efficient flight path. If it encounters unexpected obstacles or comes under fire, it can execute high-G evasive maneuvers in milliseconds, far faster than any human pilot could react. In the final seconds of an attack, precision is everything. The Bolt M's terminal guidance system locks onto the target's most vulnerable point, such as the command bridge or fuel storage. Even if the target is moving at high speed or executing evasive maneuvers, the AI adjusts its control surfaces to ensure a direct hit. To maintain stable flight just inches above the water, the Bolt M uses downward-facing optical flow sensor. These sensors measure the speed at which the water surface moves beneath the drone, allowing it to maintain a precise altitude and avoid crashing into swells even in high seas. The AI is not limited by daylight. The Bolt M's optical sensor package includes a highly sensitive thermal imager and a low-light CMOS sensor. This allows the AI to detect and track targets in absolute darkness, dense fog, or through thick smoke screens, ensuring 24-hour operational capability. While the drone is capable of fully autonomous flight, it also supports man-in-the-loop operation. This allows a human operator to monitor the mission in real time and make the final decision to strike or abort. If aborted, the drone can return to a designated recovery zone or loiter safely. The Bolt M system is designed to get smarter over time. Every flight, whether a training mission or an actual combat deployment, generates valuable data. This data is fed back into the central neural network, allowing engineers to continuously update the AI algorithms and improve target recognition capabilities worldwide. A single Bolt M drone is a dangerous threat, but a swarm of them is a catastrophic event. Swarm tactics represent the pinnacle of asymmetric warfare. By launching dozens of drones simultaneously, a small force can overwhelm even the most advanced, multi-layered air defense systems through sheer numbers. This is not just a group of drones flying together, it is a collaborative network. The drones communicate with each other using a decentralized mesh network. If one drone detects a threat or a target, it instantly shares that information with the entire swarm, allowing them to coordinate their actions without human input. When the swarm approaches a target group, the AI-driven mesh network automatically allocates targets. Drone A might target the ship's main radar, while drones B and C focus on the defense turrets. This ensures that no two drones target the same asset unnecessarily, maximizing the efficiency of the strike. Modern warships rely on close-in weapon systems, or CIWS, which are rapid-fire radar-guided guns designed to shred incoming missiles. However, a CIWS can only target one object at a time. A swarm of Bolt M drones approaching from multiple vectors simultaneously will quickly saturate and overwhelm the system's tracking capacity. The swarm can also utilize decoy tactics. Several drones in the swarm can be programmed to act as high-visibility decoys, intentionally drawing the fire of the ship's air defense systems. While the ship's defenses are distracted by the decoys, the remaining armed drones execute their low-altitude, high-speed attack runs. If a drone within the swarm is destroyed, the remaining drones instantly recalculate their mission parameters. The mesh network redistributes the lost drone's target to another active unit, ensuring that critical targets are still destroyed. The swarm behaves like a single self-healing organism. Launching a swarm does not require a massive, synchronized effort. Drones can be launched from different locations at different times. The AI coordinates their flight paths in real time, ensuring they all arrive at the target area simultaneously, maximizing the element of surprise and overwhelming force. For non-kinetic missions, such as multi-angle surveillance, the swarm can coordinate its own recovery. Once the mission is complete, the drones return to their designated landing zones in an orderly sequence, landing one by one to avoid collisions, ready to be packed away and recharged. The psychological impact of a swarm attack cannot be overstated. Facing a swarm of silent, intelligent, and highly coordinated killer drones is a terrifying prospect for any crew. It degrades the enemy's morale, forces them to operate under constant stress, and can lead to tactical errors and decision paralysis. As AI technology continues to advance, the capabilities of these swarms will only grow. Future iterations of the Bolt-M will feature even higher levels of collaborative decision-making, allowing them to conduct complex, multi-domain operations across land, sea, and air, reshaping the future of global conflict. The emergence of the Bolt-M has profound geopolitical implications. For decades, global maritime power has been concentrated in the hands of a few wealthy nations with massive navies. Now, smaller nations with modest defense budgets can acquire a highly effective deterrent, challenging the traditional balance of power. Consider the economics. A modern destroyer costs upwards of $2 billion to build, and millions more to operate. A single Bolt-M drone costs a fraction of that. If a swarm of 10 drones costing less than $1 million can disable or destroy a $2 billion ship, the economic math of warfare is completely broken. For nations like Australia, with vast coastlines and a relatively small population, the Bolt-M is a game changer. It allows for the deployment of a highly distributed, flexible coastal defense network. Small mobile units can monitor and protect thousands of miles of coastline, deterring any potential aggressor. The Bolt-M is also uniquely suited for gray zone operations conflicts that fall below the threshold of open warfare. Because of its small size, stealth capabilities, and modular payloads, it allows nations to project power and deter aggression without escalating to full-scale military conflict, maintaining stability. However, this technology also presents significant risks. The low cost and ease of manufacture of microdrones make them attractive to non-state actors, insurgent groups, and maritime pirates. Controlling the proliferation of advanced drone technology is becoming one of the greatest challenges for international security. In response to the drone threat, a massive counter-drone industry has emerged. Militaries are scrambling to develop directed energy weapons, high-power lasers, and electronic jamming systems. It is a classic technological arms race. As drones get smarter and more stealthy, defense systems must evolve to keep pace. The use of autonomous AI in weapon systems also raises profound ethical questions. Should a machine be allowed to make the decision to take a human life? While the Bolt-M supports human-in-the-loop control, the pressure to operate at machine speeds in a conflict may force nations to rely entirely on fully autonomous systems. The future of naval warfare is not about replacing humans with machines, but about human-machine teaming. The Bolt-M acts as a force multiplier, enhancing the capabilities of the individual soldier. It allows human decision-makers to operate at a safe distance while the machines handle the high-risk tactical execution. We are standing at the dawn of a new era in military history. The Bolt-M is a testament to the power of innovation over raw size and wealth. It proves that in the 21st century, intelligence, adaptability, and agility are the ultimate weapons. The giants of the ocean must adapt, or they will face obsolescence. Thank you for watching Science Aura. If you enjoyed this deep dive into the future of maritime technology, please like, subscribe, and leave a comment below. What do you think? Will micro-drones completely replace traditional warships? Let us know your thoughts. Until next time, I'm Dr. Sachi Vale.